Hi, ladies and gentlemen. I welcome you again to our YouTube channel. Please don't forget to subscribe, also like and comment. Ne? You can also share the video with your fellow learners. So today I will be showing you guys how to answer the cubic function and calculus. Ne? So let's have our question here. Okay, guys, here's our question. So we are given two graphs, ne? We are given g of x is equals to x cubed minus 3x squared, and the h of x, which is minus 2 over 3x minus 4 over 3. Then the first question says, determine whether the graph of h intersects the graph of g at its point of inflection. Ne? So, okay, the first thing that we have to do in this question is to determine the point of inflection. Ne? So, to determine the point of inflection of our function, which is g of x, is to do the second derivative and then equate it to 0. So, let's go. Let's differentiate our function. Then g prime x equals to what? It will be 3x squared minus 6x. Ne? Then the second derivative will be it will be 6x minus 6. Ne? Then at the point of inflection, the second derivative is equal to 0. Ne? So it means 6x minus 6 equals to 0. Then obviously our x here is going to be 1. Ne? I hope you all know how to solve for x. Then we are not done. We have to get the corresponding value of y. To get the corresponding value of y, we substitute our x to the original function, which is g of x. So let's go. G of 1 will be equals to 1 cubed minus 3 into 1 squared. Then this thing is the same as 1 minus 3, which is minus 2. So our point of inflection is 1 is to negative 2. I hope we are still together. So okay, don't forget our question was not to find the point of inflection only, but was to determine whether the graph of g intersects the graph of g at its point of inflection. So it means now we have to check are this graph intersecting at the point of inflection. How do we check? Ne? So because now we are having the point of inflection, it's gonna be simple. So what we have to do here is to take the value of x, ne, which is 1. If we substitute it to the graph of h, ne, when it gives us negative 2 or the very same y value as the g of x, ne, or this one of negative 2, it means the graph intersect each other. So let's test. Then h of 1. If h of 1 also gives us negative 2, it means the graph intersect at the point of inflection. So let's check this thing. Then where there is x, we'll substitute 1 minus 4 over 3. Ne? Then this is minus 2 over 3 minus 4 over 3. It will give us negative 2. Ne? You can check with your calculator. Then, okay, since these things are the same, or when the x is 1 in both graphs, we get the very same y. Ne? It means they intersect at the point of inflection. So we can conclude and say, therefore, h intersect g at its point of inflection. At its point of inflection, ne? For 6 marks. We are done. Let's go to the next question. Let's go to the next question. The next question says determine the stationary point of y. Our y is equal to the derivative of g. So you must be very careful here. You are not determining the stationary point of g of x, no, but the stationary point of the derivative of g. Ne? Okay, so the equation is y is equal to the derivative of g, which is the same as y equals to, if we differentiate g of x, we'll be getting it is 3x squared minus 6x. So we must determine the stationary point of this function, ne? Not g of x. So this is a parabola, so it is simple. You can use minus b over 2a because a stationary point is the same as the turning point. Don't forget that. Ne? So you can use minus b over 2a or use the derivative way. Ne? So I can differentiate these things fine. Or okay, let me use the other method, minus b over 2a, because it's a parabola, you can see. Then our b here is negative 6 over 2 multiplied by 3. This thing will give us 6 divided by 6 is 1. Okay, ne? Then we have to get the corresponding y value because we need to find the stationary point. So we have to substitute that x value at our original equation. We have to substitute it on our original equation, y equals to 3x squared. So it will be 3 into 1 squared minus 6 times 1, because it was 6x. This thing will give us -3. So the stationary point is 1 is to -3. It also says to classify the stationary point as either maximum or minimum. So we have to determine whether the stationary point is a minimum or a maximum. Okay, you know, if the value of a, the parabola will be like this, right? If the value of a is negative, then it will be like this. Then here, the value of a is positive. Obviously, our function will be like this. And when the function is like this, our turning point will be here. And we are having the minimum turning point or minimum stationary point. So it means that point is a minimum stationary point. You understand? It's a minimum stationary point. So you can come here and say, okay, this is a minimum stationary point. Or we can test using the second derivative. You can test using the second derivative, but it will take time. So let's just say, okay, this one is a minimum turning point or minimum stationary point. Okay. Yeah, minimum stationary point, because the value of a is positive, and the graph will be like this. Obviously, here we're having a minimum turning point. You can all see that. Okay, then let's go to the next question, 8.3. You can pause the video and copy everything. 8.3 says what? Determine the values for x which g is concave down. Okay, if our g, or if a function concave down, it is where the second derivative is less than 0, or where the second derivative is negative. So we must find the second derivative. I think we found the second derivative in question 8.1. It was 6x minus 6. I hope we all remember this one. So we can write this for concave down. For concave down, the second derivative is less than 0. So it means 6x minus 6 is less than 0. Then x will be less than 1. I hope you know how to solve an inequality. This is a linear inequality. You fit this into 10. Then that's all about to determine where our function is concaving down. Perfect. So for concaving up, it means the second derivative is greater than 0. Then, yeah, that's all. Don't forget that at point of inflection, the second derivative is equals to 0. Then from concave down, less than 0, second derivative. And then for concave up, greater than 0, second derivative. Okay. Then let's go to 8.3.2. The gradient of the tangent to g at its point of inflection. Okay, the point of inflection was 1 is to -2. So this is simple, guys. So to determine the gradient of a tangent to a function, it is equal to the derivative of the function at that point. So it means we must do the derivative. The derivative of g is equals to 3x squared minus 6x. We have calculated this one, or we know how to differentiate it. So we have to substitute our 1, because we will need to find the gradient of the tangent at that point. So g prime 1 will be equal to 3 multiplied by 1 squared minus 6 times 1. This will give us -3, right? Yes. So it means this is the gradient of the tangent at the point of inflection. Gradient of a tangent to g at the point of inflection. You add that. It's -3. I hope you are still following. Then let's go to 8.3.3. They say a student claims that the gradient of g at any point will never be less than -3. Okay, if this student claims that the gradient will not be less than -3, it means something that cannot be less than, or okay, if we say the gradient cannot be less than -3. In other words, we are saying, okay, that -3 is our minimum gradient, because you know there's nothing that can be less than a minimum, right? So it means this student claims that -3 is our minimum gradient. Okay, then is the student correct? Explain. Okay, don't forget, the gradient has its own equation, which is g prime x is equals to 3x squared minus 6x. The derivative is the gradient, so you must find the minimum value of this function. That's all. Because this is the gradient. The derivative is a gradient, so you must find the minimum value of this function. And this function, it's a parabola. You understand? It's a parabola. You can see that. And you know, a parabola, this a is positive, so it will be like this. And the minimum value, we are using the y value. Don't forget, the turning point is p as to q. So this q, this q, or the value of y at the turning point, becomes our minimum value. So it means in this equation, we must find the value of q, or the value of y at the turning point. So I'll write it in this fashion so that it can be clear. Like this. A into x minus p squared plus q. That q will be the value of y at the turning point and will be the minimum gradient. If q get negative 3, then this student is correct. If we don't get that negative 3, then the student is wrong. Let's prove. Okay, we need to write it in this fashion. So let's go. You can take out your common factor, which is 3, and then left this thing, because we need to do a completing square here. And then the derivative, and then if we do a completing square, we'll be having x squared. Oh, yeah, it's not minus 6x. It will be minus 2x. Okay. Then minus 2x here, because we have factor out with 3. Then plus 1. We have to also subtract that 1. 1 minus 1 is 0. So it's like when I'm adding a 0, nothing gonna change. Then this thing, we can factorize it. I mean the first 3 terms. This one can be factorized as x minus 1 into squared, then minus 1. All right, then let's make it to be like that one of a into x minus p squared plus q. Don't forget that. It's our main aim. So okay, now we have to multiply everything with 3. Y equals to, or the derivative, because we are talking about the gradient. A gradient is a derivative. The derivative of g is equals to 3. When you multiply with 3, 3 multiplied by x minus 1 squared, 3 multiplied by negative 1, it will be minus 3. So indeed, the second derivative has, or the gradient, our minimum gradient is negative 3. Yes. Then that's it. There will be no gradient that will be less than negative 3. No gradient that can be less than negative 3. So indeed, that negative 3 is our minimum gradient, because I told you we must get our q, it's a negative 3, because that the value of y at the turning point for parabola, it always determines it's a maximum or a minimum. If a graph is like this, then we're having, okay, let me use numbers so that it can be simple. Let's say we are having 1:3. So this 3, the value of y at the turning point, because it's like this, a is negative, so that 3 becomes the maximum value of our function, the value of y at the turning point. So when it is like this, let's say we're having negative 1:7, that 7, the value of y at the turning point, becomes the minimum value of the graph. So because the derivative, as I've said, is the gradient, yes, so it's the minimum gradient. You understand? It's the minimum gradient. Yes, it's the minimum gradient, because that's the equation of a gradient. So yeah, indeed, there will be no value of, or there will be no gradient that can be less than negative 3. Negative 3 is our minimum gradient. So the student is correct. Therefore, the student is correct, because we can write minimum gradient is negative 3. Yes, the student is correct. The student is correct. Perfect. Because yeah, that's what we have to prove. Then we have proved it. Then let's continue, guys. Let's continue with our thing. Let's continue with our thing. Then okay, now we need to find we have to answer this last question. Determine the value of k if the graph of g is shifted so that the values of x for which the new graph. Our new graph is p of x. Né? It is determined as x plus k, then there's a cubed minus 3 into x plus k, then squared. All right, perfect. This thing, it means g has been shifted k units to the left. If you see plus, it means to the left, shifted to the left. So it is shifted k units to the left. Then we must find that k. Then, okay, but this function decreases between -3 and then -1. Okay, one thing we have to understand, where the graph is increasing or decreasing, we use the stationary points. Always, when we're talking about where the gradient is increasing or decreasing, where the function is increasing, I mean not gradient, because now we're talking about the function. Where the function is increasing or decreasing, we are using the stationary points. So it means we have to find the stationary point of g of x firstly, so that we can understand the movement or the shift that has taken place. So let's do these things first. Then g prime x, because when we want to find the stationary point, we have to do the derivative. It will be 3x squared minus 6x. Perfect. Then the first derivative is equals to 0 at stationary point. At stationary point. Then it means 3x squared minus 6x will be equal to 0, and then we can take out 3x as our factor, and then we'll be left with x minus 2 equals to 0. X will be 0 or x will be -2. There's no need for us to find the corresponding value of y. We use this value of x. So it means g, or let's rough sketch g of x. It's a cubic function, so it will be like this. Then here, obviously, it will be 0. Then here will be -2. I'm just writing the corresponding value of x only. Yes, I'm just writing the value of x only. Don't worry about the value of y. Then you can see this function is decreasing here, between 0 and -2. So okay, g of x is decreasing between 0 and -2, isn't it? Yes. Oh, we start with the small value. Yes, we have to start with the small. Oh, it's not -2, it's +2. Sorry guys, sorry for that. It's +2. I made a mistake. It's +2. Yes, so the graph of g decreases between 0 and 2. 0 and 2. Okay, so you have to see the translation. From 0 to -3, it's how many units? 3 units to the left. From 2 to -1, still it's how many units? 3 units to the left. You can write 2 minus 3, you get -1. 0 minus 3, you get -3. So it is 3 units to the left. So okay, we can see, oh, g has been translated or has been shifted 3 units to the left. G has been shifted 3 units to the left. Okay, so it means in other words, p of x, I get it, is when g is shifted, it is x plus 3 squared, not squared, cubed, minus what? 3 minus 3 into x plus 3 squared, right? Yes. So meaning k is 3. Then we are done. Thank you guys for watching this video. Don't forget to subscribe and also share the video with your fellow learners and like. Thank you.